welcome to this MIDFIX podcast.
Thank you, Stephen.
This session today is on fire stopping. Joining us today is Andrew from Protecta. They're an international UK-based manufacturer of fire stop products. And Andrew, just before we start, I think it'd be wise if I just go over your background a little bit. So, 20 years experience in fire stopping?
Yeah. 40 years in the construction industry, roughly.
Okay,
so,
we won't go too far into that. 10 of those years were heading up the Hilti Fire Stop team.
That's right.
And you're the ex-chair of quite a few fire stopping organisations. So the ex-chair, I'll get this right, of the Association for Specialist Fire Stop Protection, the ex-vice chair for Fire Safety Development Group, and the ex-vice chair for the Fire Stopping Forum.
Yep.
That's
right.
Roughly encompass your career in fire stopping?
Yes, yeah. It fills in a lot of it, certainly, yeah.
Good.
Yeah.
So today's session is on passive fire stopping. Predominantly our market is the M&E building services industry. But if we can start right back at the beginning, because the audience is quite wide, goes from experienced to novice. If we can start right at the beginning, then basically what's the purpose of fire stopping?
The whole principle is to try and subdivide buildings down into fire compartments. Mm-hmm. If you take something like Grenfell, a tragedy, but if the fire could have been contained within the flat where it originally started, then we wouldn't have seen the 70 plus deaths that happened there. In schools in the UK, I read the other day that there are over 1,000 fires a year happening in schools in the UK.
Wow.
But we don't hear about them.
Yeah.
And the reason we don't hear about most of them is because the fire is contained fairly quickly within a small area and dealt with. So it doesn't grow out of proportion, and that's basically what you're trying to do with compartmentation in buildings, is subdivide a building down into fire compartments that can limit the spread of the fire and smoke throughout that building. The fire stopping, as soon as you build a fire compartment, you're going to denigrate the effectiveness of it by putting services through it.
Yeah.
So whether it's cable trays going through or even if it's movement joints within a building, all of these are routes for fire to spread between fire compartments. So fire stopping is basically designed to reinstate those areas. If you have a plastic pipe going through a wall, and that burns away, you're left with maybe a 110 mil hole through that wall. So by putting a fire stop product around it, that is going to fill that void before the fire and the smoke can travel through.
Great. So basically, once one of our M&E contractors has arrived on site and punched a hole in a firewall and put the services through it, that's basically ruined any fire integrity of that particular wall.
Yes,
so that
absolutely.
Service penetration then needs to be made good again, yeah?
Exactly, yes.
Okay.
Yeah.
So in making it good then, how does the actual fire stop products work?
Well, they work in a variety of ways. If you take a basic sealant, sealants often work by forming, they burn. If you take some acrylic sealant and you put a mass of it on a desk and take a blowtorch to it, you will find that it burns.
Right.
But what it does, as it burns, it forms a jar, and it's that jar that then protects the fire from going through. So basic sealants can give up to 2 hours fire protection around even smaller plastic pipes. But then the vast majority of fire stopping technology is based on graphite technology, because graphite expands greatly, and it has the ability, when it expands, it produces pressure which can crush down pipes, can crush down, take up the gap left by cable sheathings, etc.
Yeah. Okay. And it's that actually closes the penetration back up again. Yeah.
Exactly. Yeah.
Okay then. So they basically work through two sort of principles there: the charring effect, and then the expansion effect.
Yes.
Okay. Good.
Yeah.
So that's all well and good. I've noticed on the marketplace there are a wide variety of different fire stopping products. There's different accreditations behind them all, there's different legislation behind it, so it seems from an outsider. What can be done then for the contractor to ensure a compliant installation? What do they need to do with the products? What do they need to do with the install?
The first thing is to make sure that the product that they install carries third-party certification. It's not a legal requirement to use third-party accredited products, but it is there in the building regulations, and more we're seeing main contractors insisting that that both the contractor themselves are third-party accredited,
right.
i.e. they're having their work checked by an independent company to go and make sure that the work is done correctly, but at the same time the products are being checked, and this is really right from the design stage through to the manufacturing, through to the install of the products. So a third-party certification of a product, they will come in, they will audit your factory processes to make sure that what you are actually selling into the market is exactly what was tested in the laboratory, and that the two things match up.
Okay then. And when you mentioned testing there in the lab, we all know that a lab test and what happens in real life tends to be two different things. So what happens in that lab test? How do you test your product? Do you look at the penetrations? Are they variable? Do you look at the services that are going through? Is that variable as well?
Yes, I mean, we test to an EN standard, and the good thing about the EN standard, in the main it's EN 1366. It will vary depending on what you're actually trying to test. But the good thing about the EN standard is that all the different manufacturers out there, if we test to the EN standard, you can compare results between manufacturers because the rules are specific.
So they're like for like then?
Yes, they are, yeah. Whereas in the past, the test standard used to be a BS 476 standard, which is what we would call an ad hoc test. And there, 4 manufacturers could test the same product, but we could pick different size openings, different constructions to test them in, and there was no comparison for a company like yourselves or one of your customers to actually look at comparing apples with apples. So now, by testing to the EN standard, clients are able to look and compare and see what can actually achieve the required
and I'm assuming
performance.
I'm assuming in the test then you are testing in variable penetrations. It's not always in a concrete wall, is it?
No.
Right.
The rules state that there are different substrates that you can test in. Often you will test in the worst case scenario, which would be drywall, often for wall construction, because the drywall will move in a fire, whereas concrete and brickwork won't move. If you test in drywall, then you can use your products in other substrates as well.
Oh, I see. So once you've passed in the worst case, it means it's suitable for everything else above that, yeah?
Yes.
Okay, that's good. Okay. So again, on that, looking at that compliant installation, is there anything else the contractor needs to be looking at? So we've selected the product, we've made sure it complies to EN. What was the EN standard?
EN 1366. There will be other test standards, but yes, for movement joints and various things, there might be a 1363 test standard. Yes.
So what else do I, as a contractor, need to look at to get the right product?
In terms of getting the right products, yes, you want a wide range of testing on the products, because the market at the moment, post Grenfell, there's a big effort there to say that products should be tested in the actual application that they're being used in.
Right. Okay.
Now, I could go. We go down the route of having all of our products CE marked. In order to get a CE mark, I could go and do one fire test on a product and get the CE mark based on that application.
Yeah.
But as soon as any variables enter into it, if I change the thickness of the wall, the type of the services going through, that CE mark is no longer applicable.
Right.
So the wider range of testing that you have the better you are covered. And Protecta, we carry out a fire test almost every week. And that enables us to ensure that we're covering as many applications as possible.
Right. So as a contractor, again, if I'm putting a penetration in a drywall, I need to be looking at a product that's been tested in that drywall.
Yeah, and tested in that actual application. I mean, there will be times where assessments will be needed to be looked at, but in the vast majority of cases, particularly on new build, you would hope that the building is designed in such a way that standard penetration and standard applications can be applied.
Right, got you. And then how important then is the actual services that we're putting through? What part does that play in selecting the product?
The services, you can break them down really into three areas. You can break them down into combustible services that are going to burn away and leave a hole,
right,
that needs to be filled. You can then look at non-combustible services like pipe work going through metal pipes, copper pipes. One of the things that you've got to bear in mind about things like metal and copper pipes is although they're not going to burn away in a fire, they are subject to movement.
Right.
And if you take a copper pipe that has, say, hot water flowing through it, it may have cold water 1 minute, hot water the next. That pipe will expand not only on its circumference but also along its length. Mm-hmm. So the fire stopping products that are used around it have to be able to accommodate the movement of the pipe as well.
Right. Okay.
And then the third one would be various movement joints within the building. So whether it's a blockwork wall that's got an expansion joint in it, or a curtain wall, or rain screen facade where you've got movement joints at the edge of buildings. I mean, that is the sort of area that failed in Grenfell.
Right. Okay then. And on that subject of movement, it's something that I picked up on a number of sites where you've got a penetration going through a firewall. How important are the service suspension points either side of that?
Yeah, very. And this again is something that really isn't fully understood by the industry at the moment. Where a cable tray, I mean, sometimes you get meter-wide cable trays going through walls with a huge amount of services on them. If that is going through a drywall and you are fire stopping that, basically what you have is a 50mm thick piece of mineral wool, what we'd call a bat, around that's in maybe a framed out opening in the wall, and that's only held in place with sealant. So if that cable tray starts to move extensively,
which it will in a fire
exactly
scenario,
in a fire scenario, it's going to start moving. The bat itself is not going to give the rigidity that you need to keep that in place. So if your service supports supporting the cable tray are set 1 meter or 2 meters away from the wall, then they're not giving enough support to the tray for it to not move in a fire scenario. So therefore there are stipulations in the testing program of where you put your service supports, and these are usually no more than 400 millimeters away from the face of the wall or the floor penetration.
And that'll be on either side as well, won't it? Because we
on
don't know
both
which side.
Sides, exactly.
Yeah, we don't know which side the fire's going.
Yeah, I mean that's something that you should always be bearing in mind with fire, is that we never know which side fire is going to come from. So you've always got to protect from two sides.
I think that's a key point. That's the reason why I mentioned it, is because on my site visits, it's quite seldom do you see the service supports right up to the penetration where they should be.
I agree entirely. I think it's one of the areas that is least understood and needs to be addressed.
Definitely, because the contractor's gone to the trouble of selecting the right product, installing it correctly, but then forgetting about the service supports. I
mean the fire itself looks for the least line of resistance in a wall. So one of the issues that we have in the fire stop industry is different trades installing fire stop. So it would be good if just a fire stop contractor did it, but we know the realistic thing is that the M&E contractor will do some, the dry liner will do some. There will be a variety of different fire stopping. So in one wall you might have 3 different companies working on that wall. If 2 of them do it perfectly right and one of them does it wrong, the fire's not going to discriminate.
No,
It's going
yeah.
to it's going to pick the least line of resistance.
Yeah.
So if the bats fail because the cable tray is moved, then that has decimated that wall from a fire perspective.
Okay then. And another area that the contractor needs to be aware about is the actual size of the gap. That bears some importance in selecting the actual product, doesn't it?
Yes, I mean, a good example of this is Filofoams. Filofoams
Right.
have been used widely in the industry in the past to do fire stopping.
Yeah.
In general, you would say that they are totally unsuitable for fire stopping purposes, most Filofoams.
But it says on the side of the can that
It says on the side of the can up to four
Yeah.
hours fire protection.
Yeah.
In all honesty, it could say 4 millennia fire protection. The way that these foams are generally tested is in a 15 mil hole, 210 mil deep. Now, what happens is that the fire will start to burn the foam straight away, and when it gets about 80 mil into the hole, you cannot get oxygen to the front of the face, and so the flame goes out. Without the
Right.
oxygen to support it, the flame is not supported, it goes out. So it will never burn through at that size. When you open that 15 mil hole out to 40 mil, you will often burn through in less than 4 minutes. So
Okay.
Filofoams as a fire stop product are certainly not suitable unless it's very specially tested circumstances for it, and that's the crux of it. You're testing for the specific applications that you have out there. So the bigger the aperture gets, the more critical the fire stopping becomes, and the
Right.
more critical the products, and the better the performance that you need out of them.
Out of those products, yeah.
Yes.
So even on a side of a can of foam, it says 4 hours. We need to be
Read the detail.
Right. Okay.
Read the detail.
Thank you. Thank
Yeah.
you. So we've gone to a lot of trouble now. The contractor. We've selected the right products. We've looked at the makeup of the wall it's going through, or the void. We've looked at the gaps. We've made sure we've got the right products. How important then? One of the biggest variables surely must be the installation and how that is installed. So just how important is the actual quality of the installation?
Yeah, the quality of the install is key. We can do all the best testing in a laboratory condition that we like, but if the product is not installed correctly on site, or inferior products are used, then we've wasted our time really.
Right.
If you take a basic sealant, for instance, there are varying degrees of quality of sealants in the marketplace. All of them will look good on day one. But if you've got a less expensive, shall we say, sealant used that is packed with fillers, what will often happen is that as they dry out, that they start to shrink and crack.
Okay.
And if a sealant shrinks and cracks, then and cracks appear, I mean, even 1 millimeter cracks. It's not fire that kills people, it's smoke that kills people, and you're trying to ensure that no gaps appear. And a 1 millimeter gap in a fire scenario where you have very high pressures in the room where the fire is taking place, smoke is forced through those gaps. So, the install, quality-wise, it's gaps that we're looking for, really. We need to eliminate them entirely from the process. Neatness is not always a good indicator of well-installed fire stop. I have seen some quite poor-looking fire stop installs, but they're totally compliant. On the other hand, I've seen some very neat installs. If you take one of the coated bats and you see some insulated pipes going through a wall, somebody, and it's done really neatly, somebody will say to me, well, is that done correctly? And the answer is, I don't know. If you've got insulated pipes going through a wall, unless I know what the insulation is, I can't tell you whether it's done correctly. So a lot of insulation might be foil-faced.
Right.
I see it going through a very neatly installed bat in the wall, all trimmed off, and there's it's been labelled correctly. But if I don't know what that insulation is, I don't know whether that's a good install or not. So if it was rock fibre insulation going through, then rock fibre is non-combustible. So I don't need to know any more about it really. That's probably a good install. If it's phenolic or a PIR insulation, something that's likely to burn away in a fire, I would need to, unless I knew otherwise, I would need to do some destructive testing to that seal to see if a fire wrap had been installed inside the bat to crush down the insulation on it, because that insulation will burn away in a fire and leave a hole. So it's not just the neatness of the install, it's really the attention to detail, and a good contractor will, in that particular case, they would put a wrap around, they would photograph it before they then did the finishing work on it, because once it's finished you can't tell that wrap's in place. So it's important that you do good O&M manuals that show the processes that you've done.
So you've answered me my next question there. If you're saying then that you can't visually sit there and look at an install and say that is compliant and that is not compliant, how do you evidence that the installation you've just done is compliant? What steps would the contractor need to take?
Yeah, well, I think that the a lot of contractors now do use a third-party program, either Boris or Bolster. These are programs that they can enter all of their fire stopping details onto. But it's just a matter of every penetration going through should be photographed and logged, and then included in an O&M manual at the end. And labels should be affixed next to it, because one of the things that you do find with fire stopping, a lot of fire stopping is done towards the maybe an early part in a job, but the handover might be 6 months or a year later. And other contractors come along and start putting services through penetrations that have already been done. If those penetrations aren't labelled correctly and there isn't a note there to say if you re-penetrate this, it needs to be made good, then we find that sometimes the fire stopping can be denigrated before the building's even handed over. So hopefully checks are in place to make sure that that doesn't happen. But yeah, I mean, keeping good O&M manuals and labelling penetrations, I think, is the best way forward.
And I think a key thing there, if you're revisiting a penetration, it's what about the mixing and matching of products? So if the original contractors used a particular product, should you be following the same chain all the way through?
Yes, I mean that is absolutely vital, particularly in the same opening. Most contractors, most building control departments, most third-party certification people will tell you that the same product should be used throughout the building. That's not necessarily the case. But what is critical is that you cannot mix and match products that haven't been tested together within the same opening. So if you come onto site and you find a wrap has already been installed by the M&E contractor around a pipe ready for somebody to come and finish that hole off with a bat, you need to make sure that the bat is compliant and tested together with that wrap.
Right. Okay. And so the only way you'll get that is to use the same.
The same.
Right.
Yes.
Okay. Then.
Yeah.
Right. That's really good to know. That's quite interesting. Thanks for that, Andrew. One point, a quick one now. A contractor's just landed itself on our laps. We've just been awarded a project. In an ideal world, and I know it's not ideal out there, but in an ideal world, when should fire stopping be looked at? From the day that project lands on our table.
The biggest problem that I've seen over the years in fire stopping is a fire stop contractor or the M&E guy coming onto site once a lot of the work has been done in terms of forming holes, deciding where the services are going, and then they're left to pick up the pieces because it hasn't been designed necessarily in the most efficient way to do the fire stopping, and then this impacts on the cost on the project. I've seen it lead to significant overruns on projects. So really, the best case scenario is for a meeting to be held before anything's come up out the ground. really,
Okay.
between the M&E contractors that are going to be on there, any fire stopping contractor that's going to be on there, and the main contractor, to make sure that the openings where services are passing through and the types of services that are being used, and even the insulation that might be used on the services, is designed to make the job of the fire stopping the most compliant it can be.
Right.
Because we always want to try and replicate something that was actually tested in a furnace.
Yeah, yeah.
And if we can do that, then it's going to cut out a huge amount of issues that could occur through the course of the
So
site.
we know how it's going to perform, basically. Yeah?
Yes.
So best case scenario, as early as possible.
Yes.
Certainly before the penetrations have been made.
Yes.
Is that what we're saying? Yeah. Rather than going afterwards and thinking, well, how do I plug that gap now?
Absolutely.
Right.
Yes.
Okay.
Yeah.
So the
Yeah.
good bit of advice for contractors, really, get it involved as early as possible.
I mean, I've seen a few sites where the best practice is that they have demo walls actually built
Yes.
prior to the job commencing, and in those demo walls they have the fire stopping detailed there, so that any contractor that's coming in and doing work that involves fire stopping can look at that and say, okay, I now know exactly how that needs to be done on here.
We'd definitely class that as best practice, wouldn't we?
Yes.
Right, Andrew, thank you very much for that. It is a complex subject that does require a lot more time than we can afford to give it right now. So many, many thanks for your time,
Pleasure.
and speak to you soon.
Yeah. Thank you.
Thanks.